Hi students, in this class we shall be discussing mode from the chapter measures of central tendency. Okay, so mode is our topic today. It is denoted by Z or MO. Okay, that is mode. So mode is defined as the value that occurs maximum number of times. The value or the observation that occurs maximum number of times in a given set of observations. Okay, so we may have more than one mode or we may not have any mode at all. Let us see that. Let us now discuss number of modes in a given distribution for a given data. So in case if the data has only one mode, if the data has only one mode, then we say that it is unimodal. It is unimodal. In case if it is having more than one mode, okay, so the possibility is that it is bimodal. If it has two modes, it is known as a bimodal frequency distribution or bimodal data. Now, if the given data has three modes, we say that it is trimodal. Okay, if it has three modes, we say that it is trimodal. Now, we can't give names for each and every number of modes. So, what we'll do, we say that it is multimodal if it has more than three modes. Okay, if it has more than three modes, we say that the given set of data is multimodal. Okay, so this is the basic definition and types of modes in a given distribution. Let us see an example. Okay, so look at the example 1. Here we have observations as 4, 3, 8, 7, 4 and 6. We can clearly observe that the observation 4 is repeated 2 times. All other observations are repeated only, it's not repeated at all. They occur only once. Okay, so here in this case the maximum number of times an observation occurring maximum number of times is 4. So therefore the mode of this data is 4. Okay, 4, because 4 occurs 2 times and all other observations occur just once. That's it. Now let us see what happens if no observation is repeating. Okay, in case if no observation is repeated, the mode is not defined at all. Okay, the mode is not defined, or the set of data or the data has no mode. Okay, no mode. If no observation is repeated, the mode is not defined. Okay, if all observations, the same thing may happen if all observations are repeating equal number of times. So for example, we have 2 2s, okay, and then we have 2 3s, then we have 2 4s, we have 2 10s, and so on. In this case, every number is repeated 2 times. So no number occurs maximum number of times. All the values occur equal number of times. Okay, so therefore this set of observations or this data has no mode. Okay, again mode is not defined. If the number of observations do not repeat, or if the number of observations repeat, or all the observations repeat equal number of times, then we say that there is no mode. Okay, let us look at some more examples. Okay, in example 2, we can observe that if the marks of 6 students are 30, 50, 60, 35, 40 and 56. All students have different marks, so no particular mark, no particular value is repeating more than once. So therefore, there is no mode for this data. This data has no mode. That's it, and very simple. Okay. Now, let us understand how to find out the mode for a grouped distribution. Okay, if it is given in a grouped form, like if we have frequencies associated with a particular set of data, then how to calculate the mode? Okay, the formula given for mode is L1 plus mode will be equal to L1 plus F naught minus F minus 1 by 2 times F naught minus F of minus 1 minus F of 1 into class length. Okay, so what is this? We can observe that L1 is the lower class boundary of the model class. L1 is the lower class boundary of the model class. That is the class which contains the mode. We need to identify which class contains the mode. Okay, which is the model class. We have to identify that. We shall discuss with an example. Okay, same way, what is F naught? F naught or F0 is the frequency of the model class. Frequency of the model class is given by F0 or F naught. Same way, F minus 1 is the frequency of the pre-model class or the class preceding the model class. Same way, F1 is the frequency of the post-model class. Okay, and class length is denoted by C. Okay, now let us discuss some properties of mode. Okay, we shall be using this formula for solving examples, and at that time we shall take all these things in detail. What is F naught, how to obtain F naught, how to obtain F of minus 1, how to obtain F1, what is C, and what is L1. We shall discuss that. Okay, so be patient. Now let us discuss properties of mode. What are the properties that we have in mode? Okay, so the properties of mode. The first property says that the mode is affected by change in scale and origin both. Okay, mode is affected by change in scale and origin. So that is, if we have if the mode of x, say we have y is equal to ax plus b, x and y are related to each other in this form, then the mode of y is also related to the mode of x in the same manner. Okay, so that is, if we multiply b to each and every observations and add a to them, then what we have is a new set of data. Okay, so for example, if we have 2, 3, 3 and 4. Okay, for this data the mode is 3, right? The mode is 3. Okay, this is the mode of x. Okay, so x mode is equal to 3. Now this is the x values. Now in case if we get y by adding, if we have say y equal to 2 plus 5x. Okay, 2 plus 5x. Let us see this. So 2 plus 5x, what happens? The new observations will be, we multiply this by 5 and add 2 to it. So 5 2s are 10, 11 and 12. So we have 12. Okay, so 5 3s are 15, 16 and 17. So this is 17. Same way, this is also 17. And what we have for 4 becomes 4 5s are 20, 21, 22. So 22. So the new set of data y can be obtained like this. Now what is the mode of y? So that is also related in the same way. That is mode of y. Will be defined as 2 plus 5 into mode of x. Okay, so that is the mode of x. Clearly we know that it is 17. We can say that if we have a set of data in x form and we convert it to y using some relation ax plus b, then the mode of y will be equal to 2 plus 5 into mode of x. Okay, so that is 2 plus 5 into, what is mode of x? Mode of x is given to be 3. So in case if we do not have the values or the observations with us,
only the mode, then also we can find the new mode. Okay, so that will be equal to, this is 5 3s are 15, 16, 17. We get 17 here. We can observe that this value and this value are identical. Okay, so therefore our mode is defined in this way. It is affected by change of origin and change of scale. So in case if you multiply each observation by something, the mode will also get multiplied by the same number. If you multiply or divide each observation by something, the mode will also be affected in the same way. Same way, if you add something to each and every observations, the mode also will get added by the same value. Okay, so let us discuss the second property, that it is used in fashionable items, because the something which is more consumed is fashionable items. Okay, if more people follow something, then you also tend to follow that. Okay, so that is it. It is used in fashionable items. Next, it can be calculated graphically with the help of a histogram. So histogram is used to calculate mode. Histogram is used to calculate mode. Okay. Next is that all the observations are constants. If all the observations are constant, then also the mode is also constant. Okay, then the mode is also constant. If all the observations are constant, then the mode is also constant. If all the observations are constant, say for example 4, 4, 4 and like that, all observations are 4, then what happens? The mode is also 4 or the constant. Okay, if all observations are k, then the mode is also k. That's it. Now let us discuss some importance or merits of mode. It is very easy to calculate, right? We can just observe which value is repeating more number of times. So it is easy to calculate, not affected by extreme values. We just need to see which one occurs the most number of times, not the value. If the smallest value is repeated more number of times, it becomes the mode. If the highest value is repeated more number of times, maximum number of times, then it becomes the mode. Or if some middle value is repeated maximum number of times, then that becomes the mode. So it's not affected by extreme values. If you add one big large value to the given set, then it doesn't change the mode of the data. It can be determined in case of open-ended distribution. That is a positive point. Okay, so it can be determined in case of open-ended distribution without ascertaining the class limit. Even if you don't know the class limits, we can find out the mode of the given data, since it is not affected by extreme values. It can also be used to describe qualitative phenomena, right? Okay. Who is more preferred? Say for example, which color is more liked by people? If you take 10 people and ask them, if you ask 10 people about their favorite colors, you can say that color is a qualitative phenomena, right? Color is a qualitative characteristic, and which color is more liked by a person can be identified by taking that value of the mode. Okay, so its value can be determined graphically using histogram. We have discussed this thing again, as can be taken as an advantage. Okay, it is a property of mode. Now limitations of mode. Okay, none of the measures of central tendencies are free from any kind of limitations. Each one have their own set of limitations. So let us discuss the limitations of mode. Okay, in case of bimodal or multimodal series, the mode cannot be determined uniquely. Okay, definitely if it has more than one mode, then it cannot be one, right? You may have more than one value as a mode. So there may be confusions in taking decisions. In that case, we do not restrict to mode. Okay. So it is not capable of further algebraic treatment. It is not capable of further algebraic treatment. It is not based on all items of the series. So that is again a limitation. Okay. And it is not rigidly defined. The value is affected significantly by the size of the class intervals. See, if the size of the class intervals are random, the mode can be affected. Okay. Now, let us understand the relationship between mean, median and mode. Okay, what is it? There is a relationship between mean, median and mode in different situations. Let us discuss them. So, it is called the empirical relationship between mean, median and mode. Okay, in case of a symmetrical or normal distribution, the mean, median and mode are all equal. Okay, in case of symmetrical or normal distribution, mean, median and mode are all equal. In case of asymmetrical distribution, that is, the graph may be negatively skewed or positively skewed. In that case, what happens is the mean will be less than the median and the median will be less than the mode. Okay, mean, median, mode. So the first one will be less than the second one and then mode. Okay, mode will be the largest value. Okay, more number of data are connected towards the right. So positively skewed distribution, in case of positively skewed distribution, what happens? It happens that mean will be greater than the median and median will be greater than the mode. Okay, in case of negatively skewed distribution, mode will be highest and mean will be smallest. Median lies in the center. Same way, in case of positively skewed distribution, the mean will be the highest and mode will be the smallest. Median is always there at the center. Okay, it is dependent upon the position of the arrangement. Now, generally what we observe is a moderately skewed or asymmetric distribution. It is again an asymmetric distribution, but not negatively skewed or positively skewed in the large sense, but skewed moderately, either positively or negatively. Then we can use this relationship to find the mode in case if we have the median and the mean. Okay, that is, mode will be equal to 3 median minus 2 mean. Mode is equal to 3 median minus 2 mean. Okay, mode Z is equal to 3m minus 2x bar. Okay, mode is equal to 3m minus 2x bar. Mode is equal to 3 median minus 2 mean. Okay, mode is equal to 3 median minus 2 mean. Okay, this definition or this relationships were given by Professor Carl Pearsons. Okay, next we shall understand how to use these concepts using problems. Okay, we shall present situations where these concepts are applied. Okay, let us look at those problems. Let us calculate the mode for the following distribution. The following distribution is given to you, class intervals are given and frequency is given. We need not prepare anything fresh. Okay, so everything is as it is, except that I converted the class to exclusive class intervals. So these were inclusive classes, so I converted inclusive class limits to exclusive class intervals, class limits. Okay, so 350 to 369 becomes 349.5 to 369.5 and the frequencies are the same. Okay, now we shall write down the formula to find the mode of the given data. So we have mode is equal to L1 plus F0 minus F of minus 1 by 2 times F0 minus F of minus 1 minus F1 into C. Okay, so let us identify the model class. First thing is identify model class. First step, find model class. Model class. Okay, so what is the model class? Model class is the class containing the highest frequency. Okay, it appears to be this one. It appears to be 31 is the highest frequency. Okay, so therefore this is the model. This is the region that we focus. First of all. Okay, so this is the model class, MC or model class. Now this is the lower boundary point of the model class. Model class is 389.5 to 409.5. Clear? Now what we are going to discuss is how to find out L1. L1 is the lower class boundary of the modal class. L1. This is L1. So we have L1 equal to 389.50. This is 50. Okay. 389.50. What is F naught? F naught is the frequency of the, this is F naught, frequency of the model class. F naught is the frequency of the model class. F of minus 1 is the frequency of the pre-model class. The frequency of the class preceding the model class. This is F of minus 1. Okay, F minus 1, that is pre-model class. And this one, that is the frequency of the next class to the model class, is called F of 1. Okay. So we have all the values. And what is the class length? Class length is, say, this was 370 minus 350. It appears to be 20. Okay. It appears to be 20, or 409.5 minus 389.5. The class length C is equal to 20 here. Is that clear? It is 20. Now we shall put all the values into this formula and find out the value of the mode. Okay, let us use the formula. So let me bring that formula here. Okay, so we have the formula here. Now we shall put the values into for calculation. Okay, so what is mode? Mode is equal to L1. L1 is 389.50. That is 389.50 plus F naught. What is F naught? F naught is the frequency of the model class. That is 31 minus, what is that? F of minus 1. F of minus 1 we have already found out that it is 27. So it is 27 divided by 2 times F naught. 2 times F naught means 2 times 31. Okay, that is 2 times 31 minus frequency of the pre-model class, that is 27. We have 27 here, and then minus of the post-model class, that is 19, into C, 20. Okay, C is 20. So when you calculate all these things, what we get is 394.50. We get 394.50. This is the mode, and 394.50 is option C. So option C is the correct answer. Okay, we shall move to the second question. For a moderately skewed distribution of the marks in statistics for a group of 200 students, the mean mark and the median mark were found to be 55.60 and 52.40. What is the model mark? So here what we have is, see, there are total number of observations is 200 students. There are 200 students. Okay. The mean mark and the median mark were found to be mean. Okay, mean is x bar. X bar is equal to 55.60 and 52.40 is 52.40 is the median. Okay, now we need to find the mode, okay, of the given data, and mode is equal to 3 times median minus 2 times x bar, that is mean. Okay, 3m minus 2x bar, and what is 3 is 3. Median is 52.40 and minus 2 times mean. Mean is 55.60, and when you calculate this, what we get is 3 into 52.40, we get 157.2 minus 2 into 55.60, it becomes 111.2 It is 111.2. Okay, this subtraction will give you 46. Okay, the subtraction will give you 46, and 46 is our mode for this data. It's very simple. This is the property that or the relationship between mean, median and mode. It is given that for a moderately skewed distribution, the relationship will be mode is equal to 3m minus 2x bar. These are exam oriented questions. Next and the last problem for this class will be this. Okay, whether to check how mode is affected by change in scale and origin. Okay, we know that mode is affected by change in scale and origin. So therefore y is equal to 2 plus 5. If y is equal to 2 plus 1.50 into x and mode of x is 15, then what is the mode of y? We know that the mode of y will be equal to 2 plus 1.50 into mode of x. This is known to us since mode is affected by change in scale and origin. Okay, this is the property that we are using here. So in the same manner, so that is 2 plus 1.50. 1.5 can be written as 3 by 2, right? It can be written as 3 by 2, or we can write 1.50 into 15 mode of x. So that is 2 plus, what is 1.5? 15 into 15 is 225. So 22.5. Okay, 15 into 15 is 225. So 22.5. The final output will be 22.5, the double, right? So 22 is 44. So 45 is the mode of the given data. Okay, when you multiply this mode with 1.50 and add it to what we get is 45. Okay, so these are the questions that we may have, and we'll be discussing more questions in some other video where we shall take exam oriented questions in shuffling manner. Okay, so shall meet in the next class. Goodbye.